Okay, this is a 12.1 solutions video. This is my third attempt at making this thing, so I can get it right here. What we need to do, first of all, I'm not going to do all of these. I'm going to do one example from each section. Okay, write the expression for the KEQ. So let's do that first. KEQ. What I need to look at is, are they all either aqueous or gases? And the answer is yes. So I write out the expression using all three of these. I'm going to say my concentration of NH3. Remember, when I write out KEQ, it's the concentration of products divided by the concentration of reactants. So divided by my concentration of N2 times my concentration of H2. Then I look and I see, are there coefficients? And in this case, yes, there are. NH3 has a coefficient of 2, so I write that as an exponent now. H2 has a coefficient of 3, I write it as a 3 exponent. That's my expression. Steps 2 and 3 should be switched. Okay, they are out of sequence, out of order. Okay, calculate the value of the KEQ. Here's how I do that. I look at my values here and I substitute them into my expression. So I say KEQ equals 0.01 squared divided by N2, which is 1.5, times 2.0 cubed. Okay, let's go ahead and do that math. Looks like this. Oops. That looks like this. 0.01 squared divided by 1.5 times 2.0. That's going to be cubed for a grand total of 8.33 times 10 to the negative 6. Now, what you have to ask yourself, is that a big number or a small number? Well, it's really tiny, right? It's way smaller than 1, like it's a fraction of 1. 8.33 times 10 to the negative 6 is a small, small number. If your number is less than 1, okay, if KEQ is less than 1, okay, then it is reactant favored. Okay, what that means is this: during this reaction here, once it reaches equilibrium, most of it is going to be leftover reactant. Okay, very, very tiny amount of product is going to be formed. Mostly, it's going to be this reactant that's left over because it's less than 1. Okay, let's go and move on to that. You guys can do these next two, and then I'll move on to this section here. Write the equilibrium expressions for each of the following reactions. Now, this letter A has got 2 solids in it, so that's a really simple one to write out. I'm not going to do that one for you. I'm going to write this one out. This one has a solid and 2 gases. So whenever I write this expression, I write it like so. I say KEQ and I ignore this, so I only focus on these two. KEQ equals the concentration of NiCO4 divided by the concentration of carbon monoxide. And I look for coefficients. This one has no coefficient, so you leave it alone. And then this one down here has a coefficient of 4, so I write it to the 4th power. There you go. That's how that's done. Excuse me. Next, you guys can do the rest. Rank the following acids from weakest to strongest. Remember, a strong acid is product favored. Yeah, well, a strong acid, look, a strong acid is HCl, right? Not only is it product favored, a strong acid completely dissociates into product, doesn't it? Into H plus and Cl minus. We use that single arrow there to say this is a strong acid. It completely dissociates. There is no more HCl left. That dissociates. Okay? So it's very product favored. It's 100% product favored. Whereas a weak acid, HC2H3O2, forms some product, but it also goes back and forms some reactant, and your product's going to be this, C2H3O2 minus. Okay, this is weak. form some of this, but a lot of it stays in this form right here. Okay, there's a lot of leftover reactant that remains. So that's what causes this thing to be weak. Okay, it's a weak electrolyte. There are some ions floating around, but mostly it's this. Okay, so what we need to do is the number we got to find when we're evaluating these. We got to look at a number that's going to be closest to what we would see in a strong acid. Okay, a number closest to 1. Okay, so the number that's closest to 1 will give us the strongest of all of these. And then we have to rank it from weakest to strongest. So we're going to put our strongest one over here. So what number is closest to 1? Well, let's look at all of these. We've got -10. That's far away from 1, isn't it? That's very weak. Then -5 is a little bit closer. The one that's closest to 1 is going to be 10 to the -4. Okay, these exponents, as they get smaller, that means this number is getting closer and closer to 1. There's less and less zeros. So our strongest one is actually going to be HF, and we're going to put that there. We're ranking it from weakest to strongest. Weakest to strongest. Okay, so we're going to put our weakest there, our strongest there, and I'll let you go ahead and finish ranking these. Okay. Oops. I'll let you finish ranking them.